So once again, good morning, everyone. I hope you can hear me and my screen is visible. Okay, so you can hear me, right? Okay. So we were at chapter 7, and in yesterday's lecture, we had seen uh, the advantages. I'm sorry, I think we had started with functions of MANET. We had seen the functions of MANET, that the crucial functions that MANET uses, such as it forwards the packet to the next hop, and the number of hops between the sender and receiver should be minimum. It also says that delay should be minimum, and the packet loss, which is there from sender to receiver, should also be minimum. And then we had seen vehicular ad hoc network VANET. But after this function of VANET, there is also one topic known as what do you call application of MANET that I have not covered. But I will simply write the names of application. Uh, so application of MANET. This is also a kind of like 2 marks or 4 marks question in your exam. So maybe you can, you know, right here. So the first application of MANET is basically, can anyone tell me any application of MANET which you remember or know? You see, mostly it is used in military application. Why military application is because they have units, like this is 721 battalion, 720 battalion. Likewise, they have units, and they want to communicate like for any intelligence information. They cannot talk on some base station or some like infrastructure network पे बात नहीं कर सकते. So they generally use their own personal network, handheld radios they are having, और उन सब में MANET लगा होता है. So that's why it is mostly used in military applications. Uh, it is also used for personal application, such as in your hotspot and all. It is also used as vehicular uh, ad hoc network because it is a subtype of VANET. Also used in sensor network. Sensor network is a kind of personal network where we want to gather some information from the surroundings or from the environment. So to monitor the environment condition, we generally use sensor. And if you're having different types of sensor to know the conditions, then we have a complete sensor network. And it is nothing but a kind of MANET. These sensors can be movable or could be stationary or fixed. Right, then we also use MANET for emergency operations such as flood or this earthquake. These are some of it. So these are 5 applications of MANET. You can write it in brief word. I mean, they are very simple to make explain. They are not very hard. You can write the explanation precisely. Okay. So after this applications, we had seen VANET. And VANET, I told you that these are buildings or apartments or any object, and above that we have access points. Not only the base stations, but we have small held antennas which are there on the buildings or shops or any object. So these are access points, and if you're having a road or a path, and on that car is or a bike or any vehicle is moving, then that vehicle has this onboard unit, and not every vehicle has this OBU. Mostly not in like truck and all, they do not have any OBU unit, so don't compare it like that. So these cars are having like OBU unit, and is nothing but a sensor, and the work of sensor is to grab the signals of the nearby access points. So once they grab the signals, they can share the connections to the nearby car, and they will create a network chain. So this is a kind of vehicular ad hoc network that we had seen. Then we compare two technologies. One is MANET and the another one is VANET. We had seen different things here, that nodes are random in fashion because they are mobile and fixed, so they can be in any random direction they can move. However, nodes are there in regular fashion because of the road is linear. That's why nodes are also linear. Network topology is slow because uh, it is very slow because they are randomly moving, and connection and disconnections are more in manner. However, they are in linear fashion and regular fashion. Their network topology is completely fast and frequent. Um, then there is a power source for this node lifetime. Your mobile battery get discharged, then the node lifetime gets over. Here, node lifetime depends on the vehicle lifetime, because OB unit, if your car battery is completely down, then your OB unit is also down. So the next we had seen the cellular network and the ad hoc network, and we pointed out, I think, three, six, 7 or 8 points we had covered up, and I think it is pretty explanatory because we had seen this thing like third time. Then we were doing this routing, and we had seen that routing is mostly used for giving you a shortest path or a suitable path from source to receiver to forward the packet appropriately at the destination. We had also seen that if you are using wireless network with any infrastructure, and when I say infrastructure, then there could be a cell or a cluster, and inside cell there is a base station which is directly connected to any mobile station which is moving, right? But that base station is not going to route any packet or signals. They're gonna do is broadcasting, and we also had seen the diagram of that, because your mobile node is moving continuously from one cell to another cell, or maybe from one base station to another base station. So he cannot use a fixed routing path there, but instead he can use something called as broadcasting. So whenever a client is moving from one BTS to another BTS, he definitely get the call or packet or a data, whatsoever you can call. But instead, if we use routing, then routing can make packet loss or data loss or call loss, because that's why base station is not using any routing there, right? However, when we talk about in case of ad hoc network, you see the each node must be able to forward data for the other node, and we had seen a diagram. It will not forward packet directly to the receiver. Instead, he needs this small, what do you call these devices, right? Could be switch, router, hub, firewall, IDS, or anything. So the packet is going to move. It was not going to be direct. It is going to be like this. So it uses routing, right? Definitely he's going to use routing because there are many devices in between, and he needs to use routing instead of broadcasting. So this is we had seen in the previous session, and in this session we're gonna understand something called as a problem for, or a situation where how this ad hoc network is creating a little problem. So let's understand it. So as ad hoc network uses routing, this will create an extra problem, kind of problem we see. You see at time t1, let's assume that at time t1, and I need to draw a diagram also because the diagram is not going to be there. So let me draw some diagram. So I'm talking about at a particular time t equals to 1. So let's say this is a node. This is a node. Might be, this could be a node. Here this is a node, and there is this node and maybe this node. All right, so I have 5 nodes. Let me label it down. So this is going to be my N1. This is going to be N4. This is going to be N2, N3, and 5. So 5 links. Now these nodes are independent in nature, but now as because we are using routing, so routing has a fixed path in between these nodes. So let me draw the path here. So when I'm drawing a path with a blue line, it is going to be a weak link. All right. So this is path, and there is one more link from here. There is one link from here, and there is like this. So here I will say that this represent a weak link. I'm gonna write it is a weak link, and let me also draw the arrow. So the it is not like both bi-directional. It is a unidirectional thing. So the arrow is like this here. The arrow is N4 to N1. Then here N5 to N3. There is N4 to N5. Right. So these are the arrow, and maybe N4 to N2. Let's say we have these are this is a weak link, and let me draw a good link here. So this green line represent good link, and now let's say good link is going to be like this. So put it in this manner. I also have a good link between N2 and N3. This, and from N5 to N4, and there is from N3 to 5. This is a good link. Let me draw the arrow from N4 to N1 is now a good link, and there is also a link from N2 to N3. There is a good link from N3 to N5 and N5 to N4. So this is in general at a time T1, at time T at time T equals to T1 we have. So the situation is like this, and the situation is pretty simple, that I have a weak link like this in a blue line, and I have a good link like this. So what is represent here, that at time T equals to T1, the network topology. So let's say the network topology looks like this. So I have 5 nodes, 1 to 5. They are connected depending on the current transmission characteristic between them. So they are not like connected by any network administrator. However, they are connected because of the situation and the characteristic between the transmission node. They are automatically get connected as they are self-configuring. They get connected. So you see here that here N4 can so both are. I'm sorry. I think there is a. This should not be like this, but instead it is. Instead it is like this. There is a good link. Okay, so here N4, if you observe that N4 can receive N1 over a good link, you can see. But however, but N1 cannot receive over a good link. It is receiving on a bad link, right? So this is a bad link, and this N1 is receiving, and N4 is receiving on a good link. So here you see that N4 can receive N1 over a good link. However, opposite is not true. N1 receive N4 over a weak link. So the observation is that the link that we are using in the network topology is not going to be having the same characteristic on both sides. So you cannot say that if between N2 and N3 I have a very good link, then it is not going to be the same case every time. And by the way, they are not like wired connection. Remember this is an ad hoc network. So this is wireless, by the way. These paths are just to make you explain that there is a good speed. Okay, understand this. This is not cable, by the way. This is an ad hoc network, and it's not cable. It's a wireless connection between the nodes. So I'm just saying that this is speed and not cable. All right. So I'm saying that N2 and N3 are having a very good speed from N2 to N3. Okay, not the opposite. N3 to N2 I do not know about. Okay, so I'm saying that link do not necessary having the same characteristic on both sides. So at t equals to t1, there is a good link. But when I say that t equals to t2, there might be a chance that this good link converted into weak link because of the network congestion or any other problem. So here the observation is link do not necessarily have the same characteristic in both direction. Now, the reason for the reason for not having the same characteristic depends on various conditions, and the major condition is because of the antenna, and might be a transmit power that is coming uh, from the transmitting antenna or the receiving antenna. So this link, these links are completely depend on that. So reason for this is a different antenna characteristic or transmit power. Uh, you see why this is happening is because if there is a sender and there is a receiver, there might be a chance that this sender is using omnidirectional antenna. That means the signals are going to be scattered in all directions. You see that your receiver is very straight. He is sitting over here only. But what about these signals which are propagating like this? इन सब signals का मैं क्या करूंगा ये जो गए हैं इधर it is not having any there is no reason to send these signals to here because there is no receiver here. Your receiver is like in this direction. So if you are using omnidirectional antenna, then this is wastage of your signals, right? Wastage of your bandwidth, and only one signal is going to reach to the receiver. Okay, so this is basically the problem, and every sender and every receiver is using different types of antennas and different type of configuration. So that's why my link is continuously going to change from if you change your time like t equals to t1 and t equals to t2. Uh, Now another thing is if you see your N1 cannot receive N2 at all. Okay, so N1 can only send here, but N2 cannot. Sorry, N1 cannot receive. He is not getting any. N2 से कोई data N1 पे नहीं आ सकता है. Okay, क्योंकि there is no link at all. I mean no connection at all. He can only N1 can only send. So and beside this, N2 can receive a signal from N1. Okay, however it is on weak link, but that's okay. I mean he is getting at least a signal. So another thing is the N1 cannot receive N2 at all. However, the N2 receive signal from N1, at least a weak signal. Okay. So what I mean to give you here, what exactly I want to specify here is as you change the time, your network topology is going to be changed according to the time and according to the situation and the conditions. So routing, if you are using, then this kind of thing happens. So if you are now moving your at time t equals to T2, let's say now this is the time, the situation can change quite fast at time 2. Okay, so now the situation is going to be like this. I'm going to create a new diagram here, and then we're going to compare. So this is the same diagram I'm going to take. However, the path is going to be now different. So I'm having here N1, N4, N5, N2, and this is maybe N3. Label it N1, N3. And now I'm going to put the path here. So let me just draw it like this only. So if I have uh, a weak link from this is the I have a path like this, and then where is the other weak link from N3 to N2? There is a weak link. Then there is a weak link from N5 to N3. There is also a path from N2 to N5. There is a weak link from N5 to N4. There's a weak link from N1 to N4. So these are the weak links, and now the good links are going to be like N1 to N2 is a good link, and N2 to N3 is also having a good link. Now there is a good link from N3 to N5, N4 to N5. And this is the diagram from. So by the way, there is a weak link from N4 to N2 also. Yes, this is, and this is at time t equals to t2, and here this is the line. This is a weak link. Right. So you see that if you compare these two diagrams, earlier there was no path, that N2 can send to, I mean, N1 is not receiving at all. But as you can see at time 2, N1 can receive something from N2, right? At least something. Yes, definitely there is a weak link, but no problem. At least now he is getting some signal, right? And beside this, earlier it was a weak signal from N1 to N2, now it is a good signal. So you see, it just t equals to time 2, and it is a very fast time, and still you're getting a complete different network topology on the time being. So your routing is very fast here. I mean, he is going to change and adapt to the environment and the traffic condition, and is going to change accordingly. So here in the notes, the complete diagram is changed now. N1 cannot receive N4 any longer. If you observe that these two diagram, earlier N4 is receiving, okay, sorry, N1 is receiving something from N4. Now in the current time, you see that N1 is not receiving at all. It can only send. Okay, it can only send. Earlier it was sending it on a good link. Now he is sending on a weak link. You can see it's the same diagram, but change the speeds and characteristic of the signal. So I'm gonna write it over here that N1 cannot receive N4 any longer, and now N4 receive N1 only via weak link. Uh, Beside this, if you see here that earlier there is only a symmetric link, not a symmetric link, but there is only one link between N1 and N2. In the current diagram, there is a bidirectional, or you can say the asymmetric bidirectional link from N1 to N2. You can see there are two links and there is only one link earlier. So this is also you had observed. So let me put it there. Uh, Now N1 has asymmetric bidirectional link to N2. So asymmetric means both weak and good link, just like your asymmetric encryption. Bidirectional link to N2 that did not exist before. Okay? So these are some of the observations that you had seen in the routing, and this is generally called as the problem of routing. I not write here the topic like problem in routing, but this is something like you have to write. If someone asks you that what could be the problem in routing, then you can put these points to explain them. And these network patterns which I had drawn here, it is not specifically like fixed. You can change it, right, in your own वर्डिंग्स एंड इमेजिनेशन. आप इसको चेंज कर सकते हो, आपको जैसे भी एग्जाम में इसको लिखना हो. दीज आर नॉट फिक्स्ड पैटर्न्स. ओके, आप इसको एग्जाम में किसी कोई भी लिंक लेकर समझा सकते हो कि पहले ये था लेकिन अब इस टाइम में इस तरीके से चेंज हो गया. Is there any problem in routing in order to understand? Uh, any doubt? Uh, no one is saying. Okay. Okay, no problem. So assume that you understand. However, still, if you think that you do not understand, you can write in the comment section. I'm going to move ahead with the next topic is difference between a wired connection and ad hoc network. Okay, these are this is the topic, next topic, and we're gonna specifically talk that we had seen in this above diagram. हमने इसमें क्या क्या चीजें सीखी थी वही हम यहाँ point out करेंगे. So the first problem is based on asymmetric link. What do you mean by asymmetric link? It means it says that if node A receives signals from node B, then the reverse is not true. Okay, so node A is receiving, but I cannot say anything about node B. Will he get receive or not? I do not know anything about that. So asymmetric link says node A receives signals from node B, but this does not tell anything about the quality of the connection in a reverse. That is, we don't know anything about node B. Will he will he get will he receive the signal or not? So this is one of the difference. First difference, asymmetric link, and the second thing is I also need to write something here in the first point itself. So B might receive he might receive nothing, uh, have a weak link, or even have a better link than the reverse direction. Okay, so there could be chances for this weak. It could have a weak link or it could have a bad link. The next is a redundant link. And what do you mean by redundant link? It is something like a link which is used in case there is a failure, right? You see, in wired connection, there is a network administrator who is looking after your all network resources, such as cable, servers, routers, switch, everything he is looking after. So if there is any link failure happens, then he precisely know that at this location I have a link failure and he is going to fix it. But you see, there is no redundancy in the wireless network. As there is no network administrator in the ad hoc network, it is somehow impossible to find that problem, right? You cannot find the link failure problem or any problem, and because he cannot see it, he cannot fix it, right? If he cannot fix it, then there could be more redundancy comes out. So that's why the problem with redundant link, it says that a wired network uh, to have a redundant link to survive link failure. However, there is some redundancy in a wired connection, and it is controlled by network administrator, and it can fix. That means it can fix. In ad hoc network, nobody controls redundancy. There are many redundant links which can't be fixed because we can't detect the fault. This is the second problem. By the way, I need to take this diagram and put it in the doc. Take here, and this is at time. I guess here I need to put. This is a time equals to t1, and another one is time equals to t2. This is it, and then so this is the problem. So we cannot detect the fault, so that's why he cannot fix the thing. So this high redundancy can cause a large computational overhead for routing table. You see, whenever there is a problem occurs, so someone had to change the routing tables. Okay, अगर सेंडर और रिसीवर के बीच में कई सारी राउटर्स हैं, तो अगर किसी में भी प्रॉब्लम आती है, तो राउटिंग टेबल्स आपके बदलेंगे. और सपोज सेंडर और रिसीवर के बीच में सपोज करो 20 राउटर है, तो 20 के 20 राउटर्स में आपको राउटिंग टेबल अपडेट करने पड़ेंगे. You see, it is very hard to update those routing table because टाइम बहुत चाहिए उसके लिए, राइट? इतनी फास्ट ये ठीक नहीं कर पाएगा. एंड बिसाइड दिस वी कैनॉट डिटेक्ट द प्रॉब्लम. सबसे बड़ी प्रॉब्लम ये है डॉक नेटवर्क में, दैट आई कैनॉट फाइंड द प्रॉब्लम. इफ यू कैन फाइंड द प्रॉब्लम देन यू कैन रिजॉल्व इट, राइट? अदरवाइज वो प्रॉब्लम वैसे की वैसे ही पड़ी रहेगी। और उसकी वजह से जो आपका ये जो कंप्यूटेशनल ओवरहेड है, यानी कि कंप्यूटेशनल ओवरहेड मतलब कैलकुलेशन कि राउटिंग टेबल्स को मुझे कहाँ से कहाँ भेजना है, वो पूरा का पूरा करप्ट हो जाएगा, राइट? एंड दैट्स व्हाई द कॉस्ट एंड ऑल गोइंग टू इंक्रीज. So this is the bigger problem in the second part. It is a redundant link. The third problem of interference is generated because, sorry, the third problem of wired and ad hoc network is because of interference. And this interference is generated a cause of co-channel interference. A co-channel interference, I hope you know that. Well, it is something like there is one antenna. This is one antenna, and this is another antenna. There could be an other antenna. Uh, Maybe so these are access points only. Okay, so I will write here AP1, uh, AP2, and this is AP3, and you are here in somewhere. So this is you. You see, if you are asking some service from these access points, if you ask something from these access points, what will happen is they will give you the service. They will give you access point here. You can say they are clients also. Okay, they're gonna give you some service, but sometimes it will happen that these access points are using the same frequencies. So if he is using 40 kilohertz, then there could be a chance that this frequency is also using 40 kilohertz. And in some instant of time, what will happen? These frequency are going to mix match here. Okay, they are going to mix match, and this is known as co-channel interference. You had seen many times. It's not only co-channel interference, there are many interference happens in the ad hoc network, not about only frequencies. There could be interference of data, there could be interference because of the channel coding, or there could be interference because of some noise and disturbances. So interference are of many types. And this also leads to update your routing tables, right? So this is also one of the problem. The fourth and last one is the dynamic topology. You see, topology already you know that we have a fixed topology, something like star, ring, bus, mesh, hybrid, and all. Uh, but here the nodes are not stationary; they are moving. And so, if my node is moving, then I cannot have a static topology. I do have a dynamic topology. But if you are having dynamic topology, then you can understand that how many times I have to change my routing tables, right? The update, the routing table update is to be very fast from one end to another end. Uh, Sir, I have doubt about registration of gate exam. ये कहाँ से आया विकास? अभी मैं पढ़ा रहा हूँ. और रजिस्ट्रेशन ऑफ गेट एग्जाम में मैं कैसे हेल्प करूँ विकास? आई मीन आई हैव नो आइडिया अबाउट इट. आई नेवर अटेंडेड एनी गेट एग्जाम. क्या इसमें डाउट क्या है बताओ? क्या आई एम वेटिंग विकास? Now he is not asking. All right, so okay. So there is a dynamic topology. You see the nodes and its characteristic will change according to the above figures. Above figures means the figure you had seen in the routing figures. Okay, you see the nodes are changing and the characteristic of the traffic is also changing there. You had seen it here. Right here you had seen. So because of this changement, right, बहुत सारे changes एक साथ हो रहे हैं. So इसकी वजह से आपको क्या करना पड़ेगा कि routing tables को भी frequently changes करना पड़ेगा, update करना पड़ेगा. This result in frequent changes in topologies. Okay, आपकी topology change होगी. And in ad hoc network, routing table must somehow reflect these frequent changes. Okay, so it is a necessary step. So in ad hoc network, if these changes comes up, then it is required that the routing table must somehow reflect those frequent changes in the topology. But when he tried to do this, changes, the time constraints uh, will be there. So इतनी जल्दी भी ये चेंजेस को नहीं कर सकता क्योंकि जैसे मैंने बताया कि अगर सेंडर और रिसीवर के बीच में बहुत ज्यादा अगर यूजर्स हैं, सॉरी, ये राउटर्स हैं या स्विचेस हैं, तो उतनी जल्दी उनमें सब में राउटिंग टेबल को अपडेट करना is not an easy task. So this dynamic topology is also going to be a constraint of routing, or you can say the difference between wireless and ad hoc network. So these are four problems here, not four problems, but the differences between a wired connection and ad hoc network. So you can write a point here that wired connection is having a fixed topology and they do not have that much of changes. However, in the wireless connection or in ad hoc network, we have frequent changes happen, and this can lead to a problem. So these are 4 points. Now you tell me, do you have any problem in these 4 points? There is no one replying. No problem. Let me take attendance today. Okay, Nish is saying no problem. All right. So okay, remember that in this chapter, uh, there is one prerequisite that you need to know about Prim's algorithm and Kruskal algorithm. ये दो algorithm आपको आने चाहिए, मतलब I think आते होंगे. They are not very hard. So in exams, if a question generates like explain Prim's and Kruskal algorithm, so I'm going to write it down here, so that you can remember. Explain Prim's and Kruskal, because it will come. Algorithm. Please explain with any suitable example you remember. They are very simple in nature. I think कोई भी आप ग्राफ बनाकर समझा सकते हो ये दोनों algorithm. So Prim's और Kruskal आपको आना चाहिए. They are important parts. So if you do not know, I will take an example and try to explain you. I do not know much about algorithm and data structure, but this is what we're gonna do lastly in this chapter. So today we only have 34 students, and this is the best way I can take the attendance. 22nd. Now we only have two topics left in this chapter. One is AOTV and another one is DSTV. Two algorithms are there which will take a complete lecture on it. So we'll understand it in our next session. So we had seen routing and difference between Okay, so 67, 16 series.
Yes, sir.
Probable date for final exam is still not come, Pratik, because uh, GTU had not started. ये क्या कहते हैं इसको, वो शेड्यूल नहीं दिया है अभी उन्होंने, ना ही यूनिवर्सिटी ने कोई शेड्यूल दिया है. But your syllabus is completed now almost. I mean, one chapter is left, so I'm not taking in a very hardcore manner. Any guess will be helpful. Any guess? See, GTU आपका खत्म, GTU का कह रहे हैं कि दिवाली से पहले खत्म होगा. GTU का जो अगर दिवाली के पहले अगर ये खत्म कर रहे हैं GTU को, तो MU में भी उसके पहले खत्म होगा, मे बी इन अक्टूबर में भी. मास प्रमोशन नहीं मिला, अरे सब मास प्रमोशन थोड़ा ना होगा अब इस बार. Mostly, yeah. I do not know about online and all. Right now, I do not have any specific